topic is govern your AI models, and the tutorial will be handled by Jelena Skalec, Marko Pap, and Dora Doljanin. If there will be time for questions, you can ask them in the Q&A section of Zoom, and you can start your tech tutorial.
Okay, so first of all, thank you for coming to this tech tutorial. I know that it's lunchtime, but we are glad that you're here today. As we wrote in our title, today's topic is going to be how to govern your AI models with Watsonx platform. So today with me, we have Dora Doljanin, who is AI engineer, and Marko Pap, who is data and AI engineer. My name is Jelena Skalec. I work as data and AI technical sales. And this is what we are going to talk about today. So first of all, I would like to give you an overview what IBM is doing today. Then we are going to give you the overview of Watsonx platform, short overview. And since it's tech tutorial, we're going to provide you 2 demos. So how to govern your large language models demo and how to govern your machine learning models demo. So what we are doing with today with Watsonx platform, maybe you have heard that recently we were working with Sevilla Football Club, and they used Watsonx AI in order to use artificial intelligence for their scouting database. So their scouting database has more than 200,000 players, and they actually use AI to analyze these players and to be more efficient, much faster, to get this, to avoid bias and to get more objective approach in analyzing players who should be playing for Sevilla Football Club. But since Wimbledon is approaching in a month, I just wanted to give you one example of what we are doing. We have partnership with Wimbledon for more than 30 years. And here is what we do. So when player is playing at Wimbledon, when they end the match, they get personalized report about their play. Then we provide dashboards and portal with all the information to the sport anchors. So if you're watching Wimbledon and you see how smart Bruno Kovacevic is and how he has all this fabulous information, actually he usually reads it from our dashboard and portal. Last year we introduced generative AI. So if you're playing if you're watching a match, you can see in a corner some fun facts about the player, about the point, about the match. But one thing that is most interesting personally for me is highlights. So in the beginning of first couple of rounds, on each court, and there are 18 courts in total. So in each court is played 4 matches per day. So it means that it can be up to 72 matches per day. And in order to generate highlights, it would take you hours to generate just one highlight for one match. With IBM, Wimbledon does it automatically. So 2 minutes after match ends, we generate highlights because we track what audience is saying. Is the audience excited? what if what players are if there was some interesting match point, if it is so tense, or if someone has broken their racket. We track everything and automatically share highlights, generate highlights 2 minutes after the match. And you can see here as an example how this highlight looks like.
Ready for play.
So you could hear audience applauding that it was something excited, and we put it into highlight. Just a short overview of what's the next platform. In May 2023, we launched What's the Next platform. It consists of 3 platforms, solutions. So we have What's the Next Data, which is our platform for scaling AI workloads, and our platform for a data lakehouse. We have What's the Next AI, which is our platform for training, validating, developing, and fine-tuning AI models. And last is What's the Next Governance, which helps you to monitor your AI models. But we are going to get a little bit deeper into What's the Next Governance in a minute. So first, you need to know that What's the Next AI is a platform where you can build traditional machine learning models and generative AI models, so large language models. When we are talking about large language models, we wanted to build open platform, which means that you can use What's the Next AI if you want to build your own models. If you maybe want to use IBM Granite model, or open source model, or a combination of IBM and third-party models. And you can actually, within What's Next AI platform, you can try it, tune it, build and evaluate it, and deploy it. Our thinking is that one model can't rule them all, and that for specific use cases, your customers are going to need different types of large language models. That's why we have a library of different large language models, and you can, by using one click, you can change it and test your solution, how it's working, for example, with IBM Granite, or how it's working with Llama 3 or Mixtral, and many other large language models. When we are talking about What's the Next AI, as I said, it's both for sorry, I just need to move this. It's both for traditional AI, traditional machine learning AI, and generative AI, because it allows you to prepare data, so to do some data refinery. Then you can work with models such as create a prompt, so working with Prompt Lab, you can fine-tune your model. If you're more into machine learning or some predictive analytics, you can use SPSS Modeler. If you're more into R or Python, you can use Jupyter Notebook. You can use Auto AI, which we are going to talk about later. And it provides you this automated model lifecycle. when we are talking about, AI is great. It's going to create a revolution, but there are some challenges, or I wouldn't say risks with AI. When you train a model, in some time it can get biased. So it's really what we need to be focused on, because when you train a model that's going to allow you to automate this loan approval for banking industry, in some time this model can be biased. So it, based on the historical data set, he's going to maybe approve loans for males that are working in IT industry. Then if you're using that kind of model, it needs to be transparent, and you need to explain it. Why did you approve loan to someone, and why did you reject loan to someone? If we are talking about deep fake, there is going to be more and more of it, and we are going to need to use our experience to know more, whether it's deep fake, whether it's misinformation or some kind of manipulation, because you cannot trust everything that you see on the news or you see in ChatGPT. And with that being said, there are some challenges and there are some risks, but there are some regulations. Today we are going to talk about European Union AI Act, which is coming, and we need to be prepared for it. And there are some others, such as United States AI executive orders and some Brazilian, UK national AI strategy and stuff like that. But we are going to talk today about European Union AI Act. So this is just how this model life cycle management could work with Watsonx governance. So Watsonx governance provides three main capabilities. These are in blue, that work together with different AI stack. So as I said, this slide provides an example of an end-to-end governed process, and it can be fully customized. So the cycle begins when actually someone in the organization identifies a business problem, and they say, okay, I have this business problem, I would like to address it with AI. Then they actually initiate the request by creating a new AI use case. And as we are going through this approval process for AI use case, Watsonx governance automatically creates documentation and notifies relevant stakeholders, including department managers, risk and compliance officers, and others. Then Watsonx governance works with virtually any build tool preferred by data scientists and AI engineers. For example, when you work with prompts, Watsonx governance automatically captures metadata such as training data, run times, and machine learning frameworks. And then as these models are evaluated, the data is continually synced with both the original AI use case and with the relevant governance dashboards, because we want to ensure that all the stakeholders and from compliance and law and regulation perspective, that you have up-to-date view on the model status and real-time report. So this solution logs facts and metrics from popular open source frameworks and from Watsonx.ai. Now, what is the most important thing which I wanted to tell you is that when you're working with Watsonx.governance, we are not talking about models that are deployed only within Watsonx.ai. No, you can use Watsonx.governance for different open source models that are in IBM Cloud or AWS, on Microsoft Azure, Google, and other cloud or on-premise providers. And you can actually deploy this governance model basically on both IBM, AWS, Microsoft, and Google. So this is what I wanted to highlight. So in order to use Watsonx.governance, you can use it for models that are created on other platforms or in Jupyter Notebook open source models, and so on. So I don't want to go into too many details, but this slide shows how the articles from European Union AI Act map onto the framework in the previous slides, and how it maps which capability best addresses each requirement. So Watsonx.governance provides documentation, monitoring, governance, and risk management for the entire life cycle across the enterprises. So Watsonx.governance actually provides this, as I mentioned before, life cycle governance, but also provides risk management and compliance, so that when someone updates a regulation or law, you can be track if you're compliant with the updates. And just one more slide before going into demo. So when we are talking about what kind of monitors we have for predictive models, we actually monitor fairness, quality, drift, and explainability. And if we are talking about Watsonx.ai Foundation model monitors, we are talking about PII, or personal identifiable information. We are talking about hateful and profane content. We can monitor quality, drift, and explainability. But I will now give the stage to Marko Pap and Dora Doljanin, who are going to show you how to create and govern your large language models, and how to create and govern your machine learning models. If you have any questions, feel free to ask at the end of the session.
Thank you, Jelena. So hi, everyone. My name is Dora Doljanin, and I work as an AI engineer in IBM's client engineering team. So as Jelena pointed out, I will be focusing on the generative AI capabilities of the Watsonx platform in this tech tutorial. So let me just share my screen and get started. Can you please confirm that you can see my screen?
Yes.
Jelena or Marko? Yes, thanks. Okay, great. So Watsonx is a comprehensive AI studio where you can work with both generative AI as well as traditional machine learning models. And it offers a variety of capabilities for enterprise. So here on the homepage of Watsonx, you can see some of the tools that are available in the platform, such as Prompt Lab, where you can experiment with different prompts and foundation models, large language models. Then there is the Tuning Studio, where you can introduce some proprietary data of your client and tune your foundation models for a specific task, making them more specialized, smaller and cheaper to host and run inference. And then there are also AI governance capabilities that let you track your AI models to ensure that they're transparent, trustworthy, explainable, so not a black box, but compliant with all of the regulations and policies. There are also a bunch of other tools and capabilities. I'm going to point out just a few of them. For example, a synthetic data generator lets you generate more than 2 billion rows of synthetic tabular data by either defining customized data schema or by mimicking the existing data. Then there is also a very powerful auto AI tool which lets you streamline the process of finding the optimal algorithms and machine learning models for a specific task. And you will actually be able to see this later in the demo. Then there are also some standard development environments such as the Jupyter Notebook Editor or RStudio for data scientists, and many others. But in this tutorial, I'm going to focus on the generative AI capabilities. So I'm going to open the Prompt Lab, which is a graphical interface where you can experiment with writing different prompts and test them with different large language models and parameters. So actually, for interacting with these large language models, you have 3 different communication channels. The first one is the chat interface, where you can converse with the model in a natural language conversational way. Then there is the structured form, where you can structure your prompts with the help of predefined input fields for specific parts of the prompt, which is more suitable for beginners who don't have much experience with prompt engineering. And then you can also write your prompts in free form, which is for more advanced users. So the easiest way to get started in Prompt Lab with working with prompts is the sample prompts library, where you have a collection of sample prompts that have been pre-made and ready to go for you to use and experiment with. And you can do this for a variety of tasks, including summarization, for example, summarizing call transcripts to get only the most valuable and important piece of information. Then there are also classification tasks, for example, classifying text based on sentiment, to either positive, negative, or neutral sentiment. Then there are also prompts for content generation, for example, marketing emails, where you can define only a few points and characteristics that you want your email to have, and the large language model will generate it for you. Then there are also extraction tasks, where you can extract specific information from text quickly and easily. Also question answering tasks, where you can find the answers to questions you're looking for based on the defined article, as well as code generation tasks, for example, generating Python code or translating specific programming language into another programming language, for example, C++ to Python, as well as natural language translation, for example, from English to French. So this is an easy way to get started. But in this tutorial, I'm actually going to show you how you can build a new prompt from scratch. So I'm going to click on New Prompt, and we're going to be using the structured mode. In this scenario, let's imagine that we have an insurance company as a client who has a number of live agents in their customer support department who are reading a bunch of car insurance claims on a daily basis. And they really need to focus on the most important parts of the claim and find the necessary information in order to proceed on to the next steps and make their decisions. So for that use case, we want to help them to boost their productivity and save time while reading these claims by summarizing them into the most important points. So for that reason, we're going to define a prompt. And here we can see different predefined fields for the different parts of the prompt. And the first part is actually the instruction, which is a statement that tells the model what to do. And here I'm going to provide the following instruction to the large language model. So you are an insurance agent tasked to assess insurance claims. Summarize the following insurance claim input. Focus on the car and the damage. Make the summary at least 3 sentences long. So after we have defined the instruction, we will most likely be needed to provide a few learning examples, because simply typing an instruction or a request won't usually yield the best results. So in this next field, we can provide pairs of sample inputs and their corresponding desired outputs. So for that purpose, I prepared one example of a customer car insurance claim, which looks something like this. So it's explaining the car incident that happened, and it specifies exactly when the incident happened, where, how severe the damage was, which type of car was involved, and so on. And then next to that input, I provide a desired output, which is the corresponding summary of that claim. And now we come to the last part of the prompt, where we can actually test our summarization prompt for different new customer claims that the model hasn't seen in the training examples. So here I prepared another example of the insurance claim, describing another accident that happened. And now we can move to selecting the model for our prompt. So for that, I'm going to view the foundation models library in the Watsonx platform, which contains all of the large language models that are available. This includes IBM's proprietary models, such as the Granite series, as well as some open source and third-party models. For example, the Mixed RAL model, or Llama 2, Llama 3 from Meta, as well as the FLAN models from Google. IBM actually has a integration with Hugging Face, a huge open source community with thousands of models and data sets, which lets you bring your own model into the platform just using a few clicks. So you have thousands of models on your fingertips, and you can easily import them and use them inside the platform. However, what makes IBM's models different from other models is how transparent and explainable they are in terms of their training data, because IBM documents all of the data sources that have been used in pre-training our models. And also IBM publishes detailed research papers for our models, which explains the exact data sources that have been used, as well as the data governance processes that have taken place, which include rigorous processes of a refinement of the data and removing any unwanted content, such as hate, abuse, profanity, personally identifiable information, copyright materials, etc. So from that perspective, IBM's transparency is truly unmatched. So once we select our model, we can click Select Model, and we will see that our model has been changed in this right upper corner. So we can see that our prompt is written in a form of text. And once we click Generate, it will be sent to the large language model that we selected. And what will happen is the process of tokenizations. So all this text will be converted into tokens. And And a token is a collection of characters that has a specific semantic meaning for a model. So sometimes one word can equal to one token, and sometimes one word can consist of multiple tokens, depending really on the large language model and the language we're using in the prompt. And after the model generates the raw output, which will again be in the form of tokens, those tokens will be converted back to words and displayed here as the output result. But before we do that, let's first explore some of the parameters that are available in the Watsonx platform that lets you really customize specific outputs of the large language model depending on the task. So the first parameter we have is decoding, which defines how the model generates the output sequence. With greedy decoding, the model will always select the token with the highest probability, and it will yield more deterministic results. On the other hand, sampling decoding will select tokens from a probability distribution, and this results in more variable and creative results. Then, once we switch to sampling decoding, we will see 3 additional new parameters, which are temperature, top P, and top K. And I'm not going to go into too much detail, but generally speaking, for lower values of these 3 parameters, the model will result in more deterministic outputs, while for higher values, they will lead to greater variability, but the model will be more prone to hallucination, which is the generation of content that is factually inaccurate or just entirely fictional. So it really comes down to finding the best values for your use case. For example, if you are solving a classification use case where you have predefined set of classes that you want your model to classify a certain text in, then you can use more deterministic parameters. While if you're solving a more creative task, such as marketing content generation, you will be leaning more towards higher values. So if you submit your prompt to the model multiple times, you might get different generated text. And this is the result of pseudo-randomness that has been built into the decoding process. So this random seed parameter is actually the number that is used to generate that pseudo-random behavior. So if you're doing prompt engineering and you're experimenting with different prompt texts and parameter values, you might want to set this random seed to a specific number, for example, 42. And that way you will know that the differences in your results are only due to your prompt text and parameters adjustments only. Next, if you notice that the results contain too much repetitive text, you can increase the repetition penalty parameter. And the higher the repetition penalty is, the less likely your model is to generate repeated text. And next, we have the stopping criteria, which actually helps us affect and control the length of our results. In 2 ways. The first one is the stop sequence. And once we define a certain set of characters, for example, the null line, the output will automatically be stopped after the defined stop sequence appears in the generated output. And also by setting the minimum and maximum number of tokens in the generated response, we can control the verbosity of the output. So for now, we have set the minimum number of tokens to 0 and maximum to 200. For this specific type of task, which is summarization, I'm going to choose the greedy decoding, so more deterministic results. And I'm going to turn on AI guardrails, which make sure that any potentially harmful input and output text, such as hate speech, abuse, or profanity, will be removed from our inputs and outputs. And now that we have defined all of this, we can click generate to send our prompt to the model. And then the large language model will append new text to it, which will actually contain the summary of our car insurance claim. And once we're satisfied with our prompt, we can actually think about deploying it and in integrating it into different external applications to use it. However, in that case, we don't want our test example to be hard-coded inside the prompt, but we actually want to send it as a variable. So I'm going to do just that. I'm going to define a new variable, which is going to be called input. And I'm going to define it over here. So the variable name will be input. And over here, as the value of the variable, I'm going to paste the same insurance claim that I used before. And right now, once I click generate, I will, of course, get the same result because that value will be sent here as a value of the defined variable. But this gives us the additional flexibility. So if we deploy this prompt template and integrate it in the application, every time we call the API reference of the deployed prompt, we can change the value of this variable. And that way we can test and run different insurance claims examples. So after we generate the results, on the bottom of the screen, we can see some useful information. For example, what was the stop reason of generating? In this case, it was a stop sequence encountered. So the new line has been generated in the output. Also, we can see the number of tokens that have been used, both the input tokens as well as the output tokens, and the maximum number of tokens that are allowed for this specific model. And finally, we can see the time that has elapsed during the generation of the results. So after we have developed the prompt, maybe we'd like to move it to production. But it's not enough just to have a functioning prompt that works well. We also need to make sure that if we're going to use AI in our business, that we can actually measure the performance of our generative AI models and also monitor them, make sure that they are compliant with all of the internal or external regulations, which is very relevant with the coming of the new EU-AI Act. And we really want to make sure that they're trustworthy, safe, explainable, and compliant. So for that reason, I'm going to show you some of the Watsonx.governance capabilities in this part of the tutorial by evaluating the prompt template that we just developed. So I'm going to choose the evaluate option, and I'm going to save my prompt template. I'm going to give it a name and select the task that it's solving, which in this case is summarization. And I'm going to save it. And now the evaluation window will open, where Watsonx.governance is automatically offering the most appropriate metrics to be used for the evaluation of this prompt template based on the task that it's solving, which in this case is the summarization task. So we can see that we're going to be monitoring the generative AI quality as well as model health. The generative AI quality will actually use a test data set that will have a set of examples of customer car insurance claims and their corresponding summaries, which are reference summaries that serve as an example of optimal results that we would like to see. And then using different metrics, we will be able to compare our newly generated summaries to these reference summaries from the test data set. Some of these metrics include Rouge, SARI, Meteor, and many others. And for the sake of time, I'm not going to go into too much detail. I'm just going to touch upon a few of these metrics very quickly. So for example, Rouge 1 will actually measure the overlapping of unigrams between our generated summary and the reference summary, which means the overlapping of individual words in these summaries. On the other hand, Rouge 2 will do the similar thing, but with a sequence of 2 adjacent words. In that case, it will also take into consideration the order of the word, which is very important for ensuring syntactical and grammatical accuracy of the text. Then the next metric is SARI, which evaluates the quality of text simplification by measuring how good the words are that have been added, deleted, or kept in the summary. And this is very relevant for the task of summarization, because when summarizing a text, what we're essentially doing is simplifying it and leaving the most important words in, while taking the less important words out. Next, I'm going to quickly touch on text quality, which actually measures standard metrics such as F1 score, precision, recall, etc. What's really interesting is sentence similarity, because what that metric will actually do is it will convert the two summaries, which are essentially texts, into their vector representations or embeddings. And these vectors will really capture the semantic meaning of those texts. And then inside that vector data space, we will actually be able to measure how close these two vectors are, meaning how close their semantic meaning is, or how similar they are. And finally, and very importantly, we are able to also measure the presence of any unwanted content in both the input and the output data. For example, personally identifiable information. So any sensitive personal information, we don't want to see that in our inputs or outputs, as well as hate speech, abuse, or profanity. And these are just some of the metrics that will be used. And using them, we can actually quantitatively measure the performance of our prompt template before moving it into production. But what's more, we can also set the thresholds for each of these metrics. And then we can monitor our prompt template in production as well, real time. And Watsonx.governance will alarm us and notify us in case of any of these thresholds have been breached. And that way, it will enable us to act in a timely manner and take any necessary steps that we need to take to ensure that our business doesn't face any major risks due to using generative AI. For example, for personally identifiable information, we can see that the threshold is 0%, as well as for hate, abuse, profanity. So we don't allow any kind of harmful content to be present in our input or output text. So after we have defined all of these metrics, we can click next. And here we can actually load our test data. So I'm going to browse my files, and I'm going to choose a CSV file containing pairs of insurance claims and their corresponding optimal summaries. And in this section, we can map the prompt variables to specific columns in the CSV file. So since I'm using a CSV, I'm going to leave a comma as a delimiter. For the input variable, I'm going to select the insurance claim. And for the reference output, I'm going to select the summary. And now I'm going to click next and evaluate. And this will take a couple of minutes. Just to save us some time, I have already run the evaluation of this prompt template. So I'm going to jump straight to the results. So here you can see some of the metrics that we've seen before, including model health. This model health actually monitors and analyzes different model deployment usage, for example, traffic, responsiveness, and efficiency of our prompts. So these are some of the more technical performance measures of our prompt template, including, for example, how many scoring requests have been made, how many records have been measured, as well as the input and output token information. This is very important because most of the large language models are actually paid based on the count of tokens that have been used. So it's really important for developers, stakeholders of the business to measure these numbers. Then we also see the API throughput, API latency, information about record throughput, and the number of users that have used our prompt template. If I go back to summary, a little bit down in the results, I can see the generative AI quality measures. So here we can see a table with all of the different metrics that we have reviewed before, and the calculated scores for each of them, as well as whether they breach any of the defined thresholds. And here we can see that for certain metrics, our prompt template has actually violated the defined thresholds to a certain degree. So this can be an indication for us to maybe do some additional prompt engineering to improve our solution a little bit and ensure compliance with both internal and external requirements. On the other hand, based on the results, we can be sure that our prompt will not generate any personally identifiable information, hate, abuse, or profanity content. As you can see, the scores for all of these metrics have been measured to 0. So that way we can really see a full picture of our prompt template evaluation results. And if I go back to my project where I have developed this prompt template, I can actually go to AI fact sheets, which is a documentation of my prompt template that is available to all of the people in the organization that is using this generative AI. In our scenario, this is the insurance company. And here, all of the stakeholders can quickly see all of the important information about the generative AI they're using, including the prompt template, the exact prompt parameters that have been used, and all of the evaluation metrics and test results, including generative AI quality, other metrics, model health, and so on. So this really shows how Watsonx is a very comprehensive platform that lets you develop generative AI solutions as well as monitor them to ensure that they are trustworthy, compliant with all of the regulations, and that way you can really make sure that you can stand confidently behind your AI. So this brings me to the end of this part of the tutorial, focusing on generative AI capabilities. And now I will leave the rest of the tutorial to my colleague Marko, who will tell you a bit more about how you can do similar things for predictive traditional machine learning models.
Thank you, Dora. So first of all, hello, everybody. My name is Marko Pap. I'm a technology engineer for data and AI portfolio of IBM Software. And today I will talk to you about how to create a predictive machine learning model with help of our service inside Watsonx platform called Auto AI, and how to govern it with help of Watsonx.governance. And we will do that through few crucial steps, which are: first, we'll need to start tracking the model, then we will need to deploy the model, evaluate it, and finally we can then explain the predictions made by the model. And in the end, we will see just how the life cycle of tracking the model works inside the platform. So let me just share my screen. Can you see my screen?
Yes.
So we are on the main dashboard of Watsonx. So just before we start, I will give you some context. So in this case, we have an insurance company which would like to assess the risk associated with auto insurance policies. Their data science team has gathered some data on various accidents around some hotspots in Chicago where traffic accidents happen more frequently. And the data scientists have found that more likely they are the file claims for insurance are more likely to happen if the proximity to the location is near to those specific hotspots in Chicago. Also, they added into the data some common risk factors such as driver age, gender, and vehicle type. And now their goal is to create a predictive AI risk model, which they want to govern and then use into their applications. So for that case, first, some business user will need to create an AI use case, which we have already done. So inside our platform, we have AI governance, we have AI use case and deployments. Those two big parts are most important for us, and projects where we actually develop the models. So we have already created an AI use case. Our risk level for this use case is medium, and we have some alerts already incorporated into the use case. So we named it auto policy risk, and inside it, we can track the models which we will connect to this AI use case. We can track their life cycle when we are in the develop phase, test phase, and later on in production. We can also add some members who can access these AI use cases and which can monitor and evaluate the models later on. But first, let's just jump back into our projects, and first we need to create the model. So inside our project, which we called DSC ADRIA, of course, we have some assets, which are, for instance, we have already created models because Auto.ai runs a few minutes, so that we will skip that part, but I will show you some details. We have Auto.ai experiment, which I will show you in a minute, and we have some training and evaluation data. So when you want to create a new model with Auto.ai, you go under new assets. We go into build machine learning models automatically, and when we defined a new model, we will, let's say, call it DSC demo. We can define the environment, some machine learning provider inside the Watsonx platform, and we click create. And now it asks us to give the data to the model. Give me 1 second. Where is this? Okay, yes, here. We add this. Wait, oh no, we can select from the project, sorry. Okay, we select the policy risk training Auto.ai data, which we already added to the project. We select the asset, and now first the Auto.ai asks us, do we create a time series analysis? We click no, because this is not the case. We are predicting just one column, and it asks us what column we want to predict. Now we have some, these are columns in our data set, so some hotspots, drivers, and some other features, and in the end we have our risk which we want to predict. And we can see that we have prediction type, which Auto.ai automatically recognizes, which he thinks is the most optimal one, and how on which metric it will be optimized. So in experiment settings, we can do some additional adjustments. For instance, we can choose either regression, either multi-class classification, time series anomaly prediction, or time series forecast as a prediction type. We can do some, so we can choose on which metric the algorithm will be optimized. So for this instance, we will choose root mean squared error, or we could maybe choose R squared or any other metrics here. Also, we can choose which algorithms Auto.ai to choose from. So here now we selected 10 out of 11 which are available. So random forest, ridge, XGB, or just classic linear regression or logistic regression. Also, we can choose how many algorithms to use in the same time. So that is more regarding efficiency. Under data source, we can do some additional data manipulation. So we can choose to drop duplicate rows, for instance. We can do feature refinement, data imputation, text feature engineering, and we can define our training data set. So we can do the training and holdout data method, which then we can customize on which percentage to choose from. And in the end, we can choose which columns that we would like to use into Auto AI creation. So we don't have to use all of the columns, but in this case, we will. So when we click run experiment, that would take a few minutes. So that part we already have done. So not to waste time, I will just jump into the actual end result, which is a dashboard like this. So when Auto AI creates models, it goes through a few steps. First, the lower part is it splits training data into holdout and training data sets. Then it chooses which two algorithms he will go. For this case, he chose one track of linear regression and one track of ridge models. And then it creates different pipelines. In this case, it creates 8 pipelines, which he then does some feature transformations. And in the end, regarding to our optimized metric, it gives us the scoring for each of the pipelines and gives us the best models. Also, we can see here under each pipeline, we have enhancements that the Auto AI has done. So for instance, for pipeline 4, which was ridge algorithm, which is the best by the metric, he first did hyperparameter optimization. He did some final feature engineering and second hyperparameter optimization. And we can also see the build time that how long did it take to Auto AI to create the actual model. And also we can see here on the right that the whole creation of all pipelines took around 6 minutes. Also, this is one view to look at this, what we can swap views and see how Auto AI did it in steps. So first it's read data set, then it's split into holdout data, read training data, pre-processing model selection, then it splits into those 2 tracks that I mentioned earlier. And then it eventually does different pipelines with first one going just the algorithm, then pipeline 2 is hyperparameter optimization, pipeline 3 is hyperparameter optimization, feature engineering, etc. So now when we created multiple models, we can choose which one we want to save. So for instance, we will choose this, which is the best one. And we can save it into 2 different ways. We can save it as a model or as a Jupyter notebook in Python. So this is a good way if you want just to make a skeleton out of a model and start creating some advanced models on top of that. So that is a good way to start, where you can just jump in with data, create few models, and start be creative and developing further more on those models. But for our purposes, we are quite satisfied with the results and we save just the model. So I also did that part already. So let's go back to our project under our assets, and we can see that we have DSC ADRIA Auto AI P4 Ridge model. That is the first one that I have run through some steps, so we can be a bit fast in this tutorial. But for this step, we'll take this model number 2. And now the first step after we created the model to start governing the model is to start tracking it into our AI use case, which was pushed on us by our business team. So we click to track the model. We click on our AI use case which want to track it in. We click next. We will, for now, use the default approach. We can be here creative. We can define new approaches. So maybe this is more advanced model, so we can just jump into testing phase or something like that. We can also assign versions. So maybe this is a patched version from some model from which was already done. So either patch change, minor change, major change, or custom. So let's say this is a patch change because we already have a same model into our use case. And then we can click next. And we can track the asset. Now, when we start tracking the asset, we can go into view more details. We'll just jump into another tab. And inside our AI use case, which is auto policy risk, we under lifecycle, we can see the lifecycle of our patched new model, which we just started tracking as DSC ADRIA Auto AI P4 Reach model number 2. So now when we go back to our model, wait, no, use cases. We need to go under deployments, sorry. And now in our already existing deployment space where we deploy the models, we need to create a new deployment. Sorry. Oh, no, new deployment space, okay. Oh, okay, yeah. Under model testing, which is the deployment space where we deploy the model, I have already connected the first model that I mentioned. So some administrative work should be done behind this, so we skip this part. But when we deploy the model, we can easily take API references, which we can use in our external applications. For instance, we have already here few programming languages with code snippets that we can just copy and paste into applications, for instance, in Java or in Python, which contains all the information that you can just start using the model. And now we will just jump into our Watson OpenScale dashboard, which is part of Watsonx.governance, where we can see some insights about our models, and we can here actually evaluate the model. So here we have our model testing, which we connected a bit earlier. As I mentioned, in between these steps, you usually need to connect some stuff, do some administrative work, which is not that important currently. So I will just focus on some important parts. So here, when we already connect the model and the use case with our Watson OpenScale, usually this wouldn't be the case of this dashboard, but we will need to evaluate the model, and we would do that by evaluating now. We would choose to import CSV file, and we could import our evaluation data, which then runs also a few minutes, and then we would get this dashboard. So after we run our evaluation, we would get some metrics, which are most important for predictive machine learning models. For instance, we have our fairness and quality. So I will quickly just jump into fairness, and we can see when it loads, it gives us a graph. And inside our data set, we have a column which is called minority. And for that, we defined some thresholds. For instance, we can see the acceptable fairness, which is on 78%. And we can see that minority is above that percentage, and that actually the model is doing very well. Also, when we scroll down, we can see that the evaluation noticed that there is some indirect bias for features, especially for hotspot 3, and we can see some additional information down here. So stuff like this can easily help you to notice how some features correlate. For this instance, correlation is quite strong of 0.37. And we can, in this way, we can notice that there might or might not be some bias integrated into data, even though there is no maybe a column for ethnicity, but maybe it's connected through other columns and it gives a different image into the data. The next step is to also to evaluate the model is that we can evaluate each line of data, so each transaction that was evaluated to the model. And let's take this one, and we have something called explain prediction option, which gives us which provides the ability to generate detailed explanations for predictive model using the LLM algorithm to generate a detailed explanation. So when we click this, it will probably take a second to generate. And here we have some quick explanation. So LLM generates explanations by modifying model input and observing the model's response. And it gives us which features had a positive influence and which features had a negative influence and by what percentage and for which value it was for these current transactions. So for this instance, this column called prim driver gender, which value was F, it had 23.7% of importance for this final output of the risk. On the other side, we have number of claims, which value was 0. It gave importance of -44%. So when we go into inspect mode of these transaction details, we can also test out for each feature or multiple features with new values. So we can, for instance, change this into M and score a new value. And we can see that the predicted outcome would change and see how, and here an engineer or the data scientist can play out a little and see how the model actually behaves and which features are more relevant or less relevant for associating risk. So now when we've done all of these steps and when we would come back to our Watsonx platform, and if we went to our AI use cases, usually it would take all of these steps and all of this would happen behind and the life cycle would be tracked. So first, when we track the model, this would happen where it would only associate with version 001. This is the actual model that we ran through. Then it would jump into testing phase, and after evaluation and deployment, we had it in the testing deployment space where it is already evaluated. And now if we jump into here into the model, we can also see some that it's here into validate phase, and we can see some additional features of and the metadata of the model, how it was prior in the develop space and now into testing space later on. And with that, we conclude our machine learning prediction model governance, and I would like to open a Q&A session.